Alright, welcome back. So the purpose of this recording is to get you some review with two of the topics that we covered last quarter. So last quarter we looked at scientific notation, which is a way of dealing with really big or really small numbers, kind of writing them in a different format so that you can kind of like picture how big or how small they are. Without having to write out a whole bunch of zeros. Like we saw in the previous videos, some of these numbers get to be just huge, so it's just easier to deal with them in scientific notation. I will also review domino conversions with you. So yeah, two topics from kind of early last quarter that are coming back for you now. We're just going to do a little bit of review to remind you of what is going on with all of those things. If you have your notes from last quarter, that is another excellent resource for you. There's tons of videos online about this stuff, and as always, bring your questions. Alright, I started this in a previous video, so I'm gonna jump ahead like 10 seconds in your life, but do write this in your notebook, because we're just reviewing it right now. Purpose of scientific notation is to deal with really big or really small numbers, is what that says. I hope you can read that. Right, so numbers like the mole times 10 to the 23rd, really big, or the size of an atom times 10 to the negative 10, that's a really, really small number. Okay, so to deal with really big or really small numbers, what you're doing in scientific notation is you're taking some of the, you're condensing the place values into an exponent of 10. So let's say you've got 8,200, yeah, just 8,200, great. And let's give you some more zeros so that you can kind of see the magic of the scientific notation deal. You could say that. I'm sure there's a word for that. Your math teacher probably knows the word for that. I could probably figure it out if I really wanted to, but I'm not going to do that because I'm working in scientific notation, which I find to be just massively superior. Because the only two significant numbers in that whole deal are the 8 and the 2. The rest of those zeros are placeholders. They're super important. We need to know how big that number is. Looking at how much or how many, we do care how big it is. However, we don't need to be figuring out which word that is, because who cares? So off we go. So you're finding your first significant number here, the biggest significant number place value that you've got. You want to put your decimal right after that first place value. So that 8 and whatever place value it's in, that's our biggest significant number. We're going to take our decimal, which we know starts here, even though we don't write it because those are not significant zeros. This is really annoying on the focus issue. This is why there are already multiple videos, is because my camera is like not focusing. Okay. Try that. Okay, so we know the decimal is implied here, even though we don't write it because that would make them all significant. Off we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we are going to put that decimal after the first significant number, the biggest place value. We're going to take all the other significant numbers with. However, in this case, we only have 2 digits that we can measure. Like, that's all we can see. And to say just how big that is, we moved that decimal 12 times. If you want to see that recounted, rewind. But we moved it 12 times, so these two numbers are the same number. And the reason that science gets so excited about scientific notation is that we tend to think, there we go, great. Okay, so feel free to pause here if you want to get that written down. But the idea here is that number is just easier to digest, because this number is saying 8.2 is significant. We could measure that 8 and that 2. And that number is real big. It's times 10 to the 12th. It's a power, like, it's, those place values are 12 place values in. It's a big number. And we don't have to figure out if that is a million, billion, trillion, quadrillion, and we don't have to, whatever. We just find it somewhat easier to hold on to those numbers as a times 10 to the something. And as the more you get like into this and the more you get the practice and the feel for it, my prediction is that you will start to just massively appreciate this system as well. Because your calculator can deal with it, because your brain can deal with it. All right, let's give you an example of something small, just to do another one in case you want to see a small thing. Here again, the only significant numbers in this entire picture are those. You want your decimal to be after the largest one that you've got. In this case, our largest one is all the way over here after all these zeros. That times 10 to the power is how many times you move your decimal to get your decimal over after that biggest place value. Off we go. So your decimal's here. This one's actually written. 1, 2, 3, 4, 5, 6. I'm moving when I'm drawing these loopies, I'm kind of drawing them under each place value that I've got. So if I've got a 0 in the 10th place, that loopy is going under that 0 all the way across. We moved it 6 times to make a small number. Since we're taking our decimal smaller, we're going to make that exponent of 10 negative. We moved it 6 times. So again, these two numbers are the same number. In this one, we wrote out the zeros and had to count them and think about them. And if you're dyslexic, that could be like an issue because there's just so many zeros. And probably shouldn't, I'm not really for all, I mean, like I find it really difficult to count that many zeros consistently that many times and should try them in your calculator, whatever. It's kind of, you can see here, these are the significant numbers, that's what we could actually see or measure, and then it's a little teeny tiny number that's 6 place values into this tininess range. Small numbers. So big numbers have positive exponents of 10, small numbers have negative exponents of 10. Okay, so that's a review on how to write numbers in scientific notation. Let's do a little math. The only types of math that I will ask you to do are multiplying and dividing. You can also, of course, add and subtract. It has to do with making all of your exponents 10 the same exponent of 10. It's kind of the same thing as lining up your decimals, and at the point that they're all the same exponent of 10, you can add or subtract like normal. I'm not going to get into that as much. What I'm going to make you do is you're going to have to know how to multiply and divide. Okay. It's also not showing up. If you are multiplying exponents of 10, so let's say you've got 3 times 10 to the 24 times 4 times 10 to the 16. Last quarter, you might have asked me, I can't put a 3 with 24 zeros after it into my calculator because my calculator is mere, most calculators can't deal with that many zeros. I can't deal with that many zeros. It's totally excessive. What we are going to do is we're going to break these into, math would say this is a base number, kind of the primary number you're looking at. I sometimes call these your calculator numbers, the numbers that you can actually put in your calculator. So those will kind of go together, and then your exponents of 10 will go together also. And we can rewrite this, because it's all just multiplying, so we're going to rewrite this 3 times 4. We're not just going to abandon these, they're coming too. Times 10 to the 24 times 10 to the 16. Okay, this part, you've got that. You can put that in your calculator, that's just fine. This is why scientific notation is nice, because you can do things like that, and it's great. And then all this stuff over here, you're like, yeah, that was fine, but here's my issue. When you're multiplying, you're going to add your exponents of 10. So when you multiply, add exponents of 10. Okay, so in this case, we've got 24 plus 16 And when we write that as your final answer, there's your 12 times 24 plus 16 is 40. That is a huge number. And kind of ran out of space on the side, so I'm going to show you this last tip down here. This is close but not quite done because we still want our decimal after the first place, the biggest place value. We want our decimal there. Currently it's here. Move it one time. Your base number is going from big to small. It's going from 12 to 1.2. We're moving your decimal one place value to take your base number from a big number to a small number. So take this exponent of 10, you're going to move that one time to make that exponent of 10 go from small to big. Okay, so small, this you want small to big. So we're starting at times 10 to the 40. Final answer. 1.2, there are your decimals after your first significant number, times 10 to the, we moved it one time, so we're going to increase your exponent one time. That would be your final answer. Now, in this level, like in high school chem, I will totally take this answer as being correct as well. You don't have to do this last step of moving your decimal. That being said, you might as well. You start to get the flavor of it and the hang of it, and it's not so bad. Putting your decimal after the first, the biggest place value that you've got. Change your exponent so that it kind of matches. We made this from big to small, so we'll make that from small to big. I would count either of these as correct. But if you're up for it, start getting yourself towards that one. Okay, so that was multiplying. Let's do that same idea, except now we're going to divide. We'll even take those same numbers, 3 times 10 to the 24. Instead of multiplying, now we're going to divide that by 4 times 10 to the 16. A lot of it is going to look really similar. Just to show you, you might see this written like this also. In fact, it's far more likely, given that we're about to do a bunch of domino conversions, that you would see something like that. Yeah, C, something like that. Great, okay. Yeah, some stuff on the top, some stuff on the bottom. We're actually gonna deal with this in a fairly similar way. So again, we're gonna break it into our calculator numbers and our scientific notation numbers. In this case, your calculator number is 3 over 4 times, and here's all your scientific notation stuff. 3 divided by 4 is 0.75. Got that. When you're dividing your scientific notation, you're going to subtract your exponents. So up here we said when you're multiplying your numbers, you're going to add your exponents of 10. When you're dividing, you're going to subtract the exponents of 10. Okay. So take the top minus the bottom. You have 24 on top. Minus on the bottom, you've got 16. Write that as, and you're right, we're gonna funk with that too because that's not done. But let's get that exponent of 10 first. 24 minus 16. Okay. And again, in this class, this is a totally fine answer. But if you're ready for it, let's take that to its actually correct form. So you want your decimal after your biggest place value. You want your decimal there. And pick it up and move it one time. And think about it. You started with 0.75 and you turned that into 7.5. This is your small number that you're turning into a bigger number. 0.75 is small, 7.5 is big. Speaking of small and big, let's magnify that. Okay, so you're starting at 0.75, you're turning that into 7.5, going from a small number to a big number, which means you're going to take your exponent the other way. So your exponent is going to go one step from big to small. Here you're starting with 8. Take that one step down. So your 0.75 times 10 to the 8 is equal to 7.5 times 10, taking it down one step, times 10 to the 7. So those are actually the same number. Again, I would take either of them as being right. That one is kind of what you're aiming for. Got your decimal after your biggest place value, and you adjusted your scientific notation exponent of 10 accordingly. Alright, I'm going to give you a second video here in just a second on domino conversions, right? So another review of last quarter, and then we'll take you to some new stuff today. See you soon.